Welcome. My team and I are going to discuss about the concurrent model in software engineering. A concurrent model is when we perform various tasks simultaneously to develop a product. My team members include Alisha Sheikh, Aryan Mansuke, Kea Chaudhary, Pradita Reddy, Chirag Gandhi, Sanskriti Dhavle, and myself, Ira Kaur. We're going to be discussing on various topics ranging from concurrent model, DFA and C in the industry, a case study, another case study, a classic example of concurrent engineering and modeling, which is a web server.
The topic is concurrent model. The concurrent model in a software engineering refers to an approach where multiple processors or a thread execute simultaneously, potentially and interacting with each other. This model is essentially in scenarios where tasks can be performed in a parallel to improve efficiency, such as multi-core processors, web servers handling multiple requests, or a real-time system.
The key points to remember about concurrent models are: the first point includes to analyze the system requirements to determine which concurrent model can be beneficial. The second point is to select the model which suits the best according to the problem domain and the system requirements. The third point is to implement the proper synchronization of data to protect the shared data. The last point is to test the concurrent system thoroughly to uncover potential issues.
Now we're going to discuss about the two main prospects of concurrent engineering, that is DFA and CE. CE stands for cost engineering. It focuses on identifying and controlling costs throughout the design and manufacturing processes. By incorporating CE principles, we ensure that our designs are not only cost effective but also feasible within our production constraints. DFA, or Design for Assembly, emphasizes on simplifying the assembly processes by reducing the number of parts and the complexity of assembly. This approach streamlines production, leading to faster assembly times and low labor costs. In our study, we studied about the Brazilian white goods industry. By applying C and DFA principles, they led to remarkable improvements in the product quality. They wanted to replace a complex assembly involving both metal and plastic parts with a single streamlined solutions, and they came up with the following four results. 1. Cost reduction. By minimizing the number of parts and simplifying the design, they achieved significant cost savings. Short tooling payback. The new design allowed them to recoup tooling costs quickly due to its efficiency and reduced complexity. Third one is quality improvement. Fewer parts and a simpler design led to higher consistency in quality and the final product, and ease of assembly. With fewer components to handle and assemble, the production processes became much more smoother and faster. This multidisciplinary approach to part development underscores the power of integrating C and DFA concepts. It not only aligns the principles with practical shop floor constraints but also drives efficiency, cost savings, and improved product quality. Now, coming to concurrent engineering, there are various cases where both of these prospects can be applied along with concurrent engineering, and a good quality product can be made.
Case study. The analysis addressed three key questions. The part did not require isolation as it was a fixed stand with no moving parts. The parts did not need different materials from the set, and there was no impediment to assembling the parts together. With three negative responses, the DFM, the DFA, and CE methodology was successfully applied to this product's development.
We can understand concurrent model using an example. So imagine you're running a busy online store. At any moment, thousands of people are shopping on your site, adding items to the cart, checking out. To keep everything running smoothly, your website needs to handle all these requests at once without slowing down. So using a concurrent model where multiple things happen at the same time, it helps the web server manage this heavy traffic efficiently. This way, your site can quickly respond to everyone, making sure they have a smooth and enjoyable shopping experience.
So how does the server work? The first method is multiple threads. Web server typically uses multiple threads to handle all the incoming requests. Each thread is usually responsible for processing a single request. The second method is concurrent processing. These threads execute concurrently, which allows the server to handle multiple requests simultaneously. The
We
third
hope you
method
liked our
is resource
PPT on
sharing.
concurrent
While threads
engineering.
do work
Please like,
independently,
share
they
and
share
subscribe for
resources
more.
like the
Thank you.
website's code, the database collections, or the network connections. The fourth method and the last method is synchronization. To prevent certain data inconsistencies, the web server usually employs synchronization mechanisms like locks.